I need to learn more about DNS. So today's room is going to be about the DNS manipulation. I know some things about DNS, but not a lot. Okay. So we entered the room. Let's spawn a machine. So there's no wait time. But DNS manipulation. All right. In this room, we will look into the DNS and showcase the techniques used to exfiltrate and infiltrate data. First, we will look at what purposes DNS serves, how it works, and the type of DNS records. Okay, we know there are some records. We know they have the C name, but most importantly, the A name, which is the address, short for address. The image below illustrates the basic DNS lookup. Here, the client machine reaches out the DNS server to resolve a fully qualified domain name, FQDN, to IP address. What is that fully qualified domain name? What is a fully qualified domain name? Is a complete address of the internet host or computer. Okay. Here the client machine reaches out to a DNS server to resolve a fully qualified domain name. So client PC types www.google.com. DNS server sends that IP address back to that client PC. If we were to do ns lookup google.com, would we get that? No, we don't. I'm guessing Google has different. I'm not 100% sure that's the thing. I'm guessing Google has different public IP addresses that are being sent to different location and or region. So for example, if I were to do this on my other computer, which I'm not gonna, I think it would show it. Nah. We will then move to how DNS is being used to use as a data exfiltration and data infiltration tool via DNS query. Client PC DNS server password dot what? Attacker DNS server. Oh. Bad script DNS server. Okay. And finally, we will look at the DNS tunneling and how it used to tunnel different protocols like HTTP through DNS. Attacker DNS server tunnel, not rc.com, internet, HTTP over DNS, secure corpse network. Installation. What do I need to install? Okay. Make DR DNS manipulation. Oh, okay. Just do that. It's much better then. Also, make sure you have required Python 3 modules in order to run the Python code. Use the following command to install sudo pimp3. We have that. Program used for DNS tunneling. This is what we just cloned. I really should not just clone repositories just because TryHackMe says so, even though it's pretty well it's safe to do so. Even though you may think it's safe to do so, it may not be. But yeah, do we have iodine? Search iodine version. Here we do. We do, and we definitely have Wireshark. I'm not going to even double check. All right, so it's done, right? Okay. What happened here? To install Python packages system-wide, try apt install where non-Kali package. Create a virtual environment using. Okay. Do I want to go into a virtual environment? I really don't know much about the virtual Python virtual environment and how to like get out and get in and all that stuff. I think it's better to do so. Create a virtual environment using Python 3, a path to environment. I don't know. Hmm. All right. I think I knew. This is going to be DNS man. The virtual environment was created successfully. You need to install. What? Was not created successfully because ensure pimp is not available on Debian system. You need to install the Python package sudo apt install Python 3.2 venv. Yes. Okay. So activate the environment. Oh my god. Oh my god. This one. Source bin. What else? Activate. Okay. Yeah, we have the DNS man. Okay. All right. So we can do pimp list. We have pimp deactivate, and we pimp list. There's a lot. Okay. Cool. All right. So sudo. Here you go. Oh, okay. So without sudo. What? Pimp R install requirements. No such file. What do you, okay. Where am I? DNS manipulation. There you go. Pimp list. So now we have these. Cool. And app install iodine. Wireshark ready. If you would like to set up the same environment as me, you will need to have a public domain name and a public server. I won't be expanding on purchasing a domain name or provisioning public-facing server as is not necessary to complete this room. However, Stoke has created an excellent tutorial on how to set everything up out of ban data exfiltration. We'll get into that later. So we have this as the top level domain name. We have the domain name and we have the subdomain name from my understanding. Okay. At the high level, the domain name system refers to naming system that revolves domain name with IP addresses. DNS servers are distributed all across the world and they are constantly being updated and synced amongst each other in a systematic way. When a user makes a request using domain names such as tryhackme.com, DNS translates this IP address to its IP addresses, then ultimately supplies the requester with the correct IP address. It's also worth noting that in some scenarios, that IP address returned by DNS won't always be the origin server's IP address if the DNS records are being proxied by a service such as Cloudflare DDoS protection. Obviously, I don't know how Cloudflare does it, but their origin DNS is being proxied by Cloudflare service. I've used Cloudflare services before, but I don't understand exactly how it works. All I know is that it's being proxied, I guess. Technically, every device connected to the internet has an IP address, which acts as which act as an identity. Say that real quick, would you? Act as an identity when communicating with other internet devices. Therefore, it's essential to understand what DNS primary functions and the hierarchy that the translation traverse. Okay, yeah, DNS root, we know that one, such as .com, .uk, .co.uk, .net, etc. Below is an illustration from Cloudflare to better picture this hierarchy. Yep. Okay, source. There are more DNS record types, however, they won't be necessary to know in order to complete this walkthrough. If you would like to learn more about the DNS records type, you can look at this article, which I will. Here we go. What are the most common types of DNS? The A record, as we all know, the address. The quadruple A record. It makes it seem like a quadruple A game. Is that how quadruple A, triple A games? Didn't Ubisoft release its quadruple A game? I don't know much about it, but the record that contains the IP6 address for the domain as opposed to the A record, which is IP4. Okay. I know that now. So this one is using the IP4 address. Well, this one is using the IP6 record. The record that contains the IP6 for the domain. Okay, cool. CNAME. This one is also forwards one domain or subdomain to another domain does not provide an IP address. What? Forwards one domain or subdomain to another domain does not provide an IP address. Okay. How does that work? CNAME DNS record illustration. Okay. Okay. All right. If you were on Windows, what command could you use to query a TXT record for YouTube? Can we use Power? Are we using PowerShell? We could give it a try. Okay. Oh, okay. NS lookup. We can use NS lookup. NS look up type equals txt and youtube.com. I think it's that one. Cool. If you were on Linux, what command could you use to query for Facebook? Facebook.com. If you were on Linux, what command could you use to query a... Okay. I didn't see that. Type txt Facebook. Are you kidding? You can't use NS lookup? Oh. Okay. AAA stores what type of IP address? IP version 6. Maximum characters for a DNS. Nay. What DNS record provides a domain name reverse? What DNS record provides a domain name in reverse lookup? Reverse lookup. Hello? Record. PTR. PTR record provides a domain name in reverse lookup. PTR. What would the reverse lookup be for the following IP address? NS lookup type PTR. What would be the reverse lookup be for the following IP4 address? Um, PTR, DNS lookup. What would be the reverse lookup be for the following? What do you, what? Uh, is a private IP address documentation available? MX Tools. Uh, I'm confused. This is it. Oh. Reverse IP address lookup. Submit. This one? Well, uh, what do you mean check my parameter? Come on. I am connected to the IP address. PTR record. PTR record. Okay. What is the maximum length of a DNS name? 253 characters. Uh-huh. Okay. In this example scenario, an attacker is trying to exfiltrate data to their system and decide their best option is going to use DNS queries. The attacker's goal is to exfiltrate sensitive information from the machine on Secure Corp's network. In this demo, I will be showing the steps that an attacker might take in order to exfiltrate the data from the compromised machine. What is that, SSH? Can't really see. SSH session into DNS server. Oh. Attacker DNS server. T-Shark capture on. The following material has been generated through fake credit card generator. All credit card information is fake. The file used for this demo are in a DNS exfil infill repo on GitHub. You will need these files to complete the rest of the room. Right, so I already have that. When packet.py is executed, you will need to supply the script with the following input. Packet.py, file name secure update, press enter. File name is the file text file recommended that you are trying to exfiltrate from the Secure Corp network. This is where you are going to put your domain name. Example, my domain name is badbaddomain.in. Okay. The code starts off by reading from the text file. The text file content will first be base 64 encoded and then base 58 encoded. This leaves us with a long encoded string. The string is then split into 20 characters long. Where each section will have 3 dummy character added to it for further obfuscation. 1 character will be prepended to the encoded string and 2 characters will be appended. For example, a section of the encoded data might look like this. After the extracted characters are added, it will end up being like this. 6GF. Once everything is encoded and ready, the code will wait for the user to press enter in order to start transmitting the queries to the DNS server. The DNS server would have already been set up to capture the incoming request with Wireshark or T-Shark. Okay. Done. Sudo T-Shark. If all goes well, if all goes well, where no queries have been lost and all the input is correct, a file with the decoded data will be saved in the same directory you ran the code from. Okay. All right. So start the machine. User password. This is the password. Okay. SSH. I don't know why I do that. Yes. All right. For this task, you will need to complete the challenge found in the challenge exfiltrate folder. Am I already in there? Nope. Tools required in order to complete this task can be found in the what? Okay. I don't want to leave it. Plus identifying orderless. A note to run the Python script. Make sure Python and make sure use Python example Python. It's very slow. And then you want me to run these. Ignore exception thrown at the end of the script. What is the transaction name? Order ID 1. Order list. Can't order? What? Okay, so these are, I guess that's the flag. I don't know. What is the transaction name? Packet grabber. Wow. DNS. This one. Packet grabber. Packet PY. Packet simple. No file was found. Okay. Order list. Uh, like that? No. Type it as you see it. I'm in there. What? No, cat. The order path class has suspicious queries. Use the packet grabber pi code. Okay. Okay. Python 3. Okay. Order PCAP. Up. I don't know what you want me to output. Output.txt, right? Bad doma.in. Cat output. Here we go. Order list firewall. How much was the firewall? 2,500. Which file contains suspicious DNS queries? 1 million THM voucher? In the identify. Identify which file contains a suspicious DNS query. Identify what domain name was used to exfiltrate the data. You can use T-Shark to filter the DNS name. Google how to filter DNS queries with T-Shark. Run a DNS and put the correct inputs in. How to filter DNS queries with T-Shark. T-Shark files. PCAP. So it's what? T-Shark version. We have T-Shark. T-Shark R. We'll try cap 1. Y. Okay. What other files? 2. 3. Oh, we got something here. All right. Which file? Cap 3 PCAP. All right. Enter the plain text after you have decoded using packet grabby DNS exfil. It's exfilled. CD packet grabber.py. Packet grabber.py. File to capture is C3P cat output. No. Cap3 P cap output 1 .txt. Bad goma.in cat output. Secure password. What is DNS infiltration? Why didn't we do this one in the beginning, man? All right. Infiltration defines a process where malicious code is ran to manipulate DNS servers, either using automated system where attackers connect remotely to the network infrastructure or manually. Okay. DNS infiltration is primarily used for file dropping or malware staging efforts, with behavioral signature-based or repetition-based threat detection system. It's possible this attack method could be caught. However, if this method is transporting data goes unnoticed, it could lead to malicious activity such as code execution in organization's environment. Historically, this has caused havoc and disruption for various well-known companies. In summary, the DNS protocol could be used to convert protocol that could aid in malware staging and execute efforts to communicate back to the attacker's C2 command and control server. What is the DNS record usually used to exfiltrate the data into a network? Oh my god. Another demo? In this scenario, the attacker is going to infiltrate a piece of malicious code onto the victim's computer. There are many different techniques that attacker can, in the real world, use to achieve this. To simplify things, I will use the TXT record that is set up on my public AWS DNS server. The value contained in the record is encoded malicious code. Since TXT records are limited to 255 characters, the hacker will most likely have multiple TXT records configured for their DNS server. This ultimately depends on how long their code is. Now that everything is set up and ready, all the attacker needs to do is request those TXT records, captures the value, decode them, and boom, they will have infiltrated their own code into a compromised system via the DNS. Okay. Um, do I understand to the hacker is using DNS TXT record to deliver or infiltrate malicious code onto the victim's computer. Oh, okay. I still can't get my head around this, but I think I get the gist of it. Files used for this demo, NS lookup. This will first look up the TXT record for the RT1 bad doma in .in, then get the value within the quotes, and finally it will save the value into a file. Yeah. Okay. Enter the output from the executed Python file. Using the VM, good thing I didn't close it, but you may use the same command in task 9 demo. Keep in mind you will need to adjust the grep section and use the appropriate characters to match on. For example, if the text value from the TXT record starts with G6, you will need to use G6. And I need to run what? For this task, you will be requesting a TXT record from my public domain name. Here is the information you need to complete this challenge. The domain name is badbaddoma.in. Request a TXT from this subdomain code. Okay. Code. So this is a subdomain code. Save the text value Python file. Code. Request TXT record from this subdomain. But there's no file here. Okay. What? I'm so like, what is going on? Use date command for more detailed. This shows it empty to 7-bit. Hang on, am I recording? Okay, I am. What? So I run this cat dot mal.py. There's nothing. Oh my god. This will first look up the txt record for the in the. So I have to do for code or code cat nothing. You may use the same command using task 9. And I get nothing. Oh. Keep in mind you will need to adjust the grep section and use the appropriate characters to match on. For example, if the text value in the TX record starts with G6, you will need request TXT record for this domain. Save the text value to a Python file, run to decode, but there's nothing in the text file. Also, it's very slow. Remove dot LA. Remove dot mal. Important for this task, use domain instead of. You're kidding. I didn't even see that. That's the domain instead of. So I need to use this subdomain and then that cat.mal. Nothing in mal again. What do I have to? If the text value from the TXT record. NS lookup TXT. Save the text value to a Python file. Run. Take note of the output and answer the question. Request TXT record from this subdomain. Save the value. What am I doing wrong? Oh, okay. So I have to look it up first. I don't know. All right. Okay. And then do this. LA cat mouse. Cat. Okay, we got it. Cat mouse. What do you want? What do you want me to do here? This? Nano Mao. Oh my god. It's so slow. What do you want me to do? Enter the output. Enter the output from the executed file. Wait, so I have to put this? I have to enter this? I don't understand. Okay. That was tough. I don't know why that had to be tough, but okay. I'm still to get started, but you want me to do more? You're saying this is supposed to take 30 minutes and it's been about an hour. Maybe my understanding of DNS isn't that good. In the previous two tasks, we've seen how DNS requests and response could be used to infiltrate and execute payloads. Yep. What do you want me to do here? What is the program used to tunnel HTTP over DNS? This is my first room upgrade in TryHackMe. I hope you understand. Yep. No, I didn't really much understand. I just saw, okay, I made a request, made a Python script, etc., etc. Okay. I might need a bit more practice with this, but I understand, not completely, but my brain still can't wrap around and try to understand this. But from this, right? Let me try and understand again. Oh my God. LSLA, we can try and do this again. So remove .mal. That is the Python script. So we did a request. What was the request? I need to look at the request. Here we go. This is the request. And it gave us that. So we have to put it in the Python file, .mal. And then we run the Python file. Here we go. Okay, out.mal.py. Okay, it has been decoded, and then we use Python 3 to execute, and we get that. Okay. Yeah. Uh, but I still need to do a little bit more research on the DNS record for the TXT. When I see TXT, I just immediately think text file. Oh my god. Okay. All right. That took longer than expected, but good room. We will use this knowledge to ethically do some research on DNS.